using Arduino as a backbone, but it's not that good with a 3D printer. This is C. Okay, straight up C. How many of you have programmed C before? Okay. So you might recognize this, but funky variables because the API is different. So your boss comes and gives you this problem. So you go to the program. And the thing with embedded electronics is you need to keep like 3 things in your mind at once. This is the first thing. This is called your schematic. I took that schematic, went to ThinkBox, and made this thing. This is a very simple board that, even though it looks fairly complicated, it just blinks an LED. And that is the source code to this board. So if you, does anyone may explain what the hell this does? Yeah. Okay. So this chip right here, this rectangle, is something called the microcontroller. That rectangle on the bottom translates to this rectangle on top, and so on and so forth. The can't really see, so I'm doing a really bad job of talking.
Yes, you are.
Keep going.
Okay. So I hate to say this, but CS is easy. I mean,
Now, baby.
like, the hardest thing you have to think about is your null pointers, right? And you can abstract a lot of nasty stuff away, right? Exactly. I know I'm the only double E here in this crowd, but.
Program memory manager, Rec City 6.
No, go away. But you have to deal with physics. Electrical engineering. Physics is a bitch. I'm sorry, it is. It's really hard. Like, for example, I screwed up on this board because I didn't think. So the LED is actually blinking the wrong way because I failed my physics class and I didn't feel like doing math. But you can't tell because I fixed it. So once you have this thing, you take your nasty board programming and you make it into a pretty picture. This. This is the file I sent ThinkBox for them to make this. So it even looks like it, right? So I did that. I spent 4 hours soldering these board together. Then I get to the fun stuff. I plugged it in and it blew up. Turns out the circuit board router was broken and they didn't cut a trace out. And the only reason I knew that was because the capacitor blew up in my face.
That's not blinking.
It actually is. It's blinking really, really fast. This board uses something called a pulse width modulation, which, if I had a chalkboard, I could explain it better. But basically, you take a square wave, which is turning on and off every, say, second. So it spends half a second on, half a second off. Except these sliders make it so that I can either be like 80% on and 20% off. And that's actually what this code is doing. This function called analog write controls the pulse width modulation signal. But we live in a world that's where communication is standard, right? So who here's ever used a serial port? Really expecting that. So you plug it in. Okay. You see how it changed color? That's because I left the program running. Then I went on Amazon and bought this. This is $20. String of LEDs. And I plug it into my board.
Ooh, oh.
So remember how I said that you combine problems? The hardware's done. The hardware took me half an hour to make. The software is all. As much as I love hardware design, software is what makes this project cool. So I open a Visual Studio because, hey, this is 3 a.m. and I want to prove a concept. So I love .NET, don't get me wrong, because it took me like 50 lines of code to do this.
That's 10 lines of C, by the way.
I don't know, I think .NET's got an advantage for opening serial ports.
Yes. But I'm not done yet, because with .NET I can do really fun math. For example, this program I really like, because what it does is this takes the average value of all the colors on my screen and sends them here. So how many of you remember the commercials with that Samsung TV where it had the light in the back? Does everyone know what I'm talking about?
Yeah.
Guess what inspired this project? And this may or may not work. Depending on how bad case the internet is right now. So it should track a movie, or in this case a TV show.
You picked a show about space to show up here.
I blame Casey's internet. My product works fine. See, look, I can even put it in paint. And it should turn red. So, that's a very crappy introduction to the world of embedded electronics. I'm sorry it sucks.
Maybe increase your bowling interval, so you
Um,
can change it faster.
I'm doing 5 million addition operations. It takes a long time.
Get a faster computer. No, multi-threaded. Yeah, can you do that? Double E?
There is no such thing as multi-threading in embedded electronics.
How do graphics cards work?
They're not embedded.
What? Yes, they are. They're just
No, they're not. They're graphics cards.
they're embedded into my motherboard.
How much does the rope blade cost?
I paid $20 on Amazon for this.
Wow.
The entire project's out-of-pocket cost was $30.
Nice.
Also, another thing, CS is free. Double E isn't. Really annoying.
Okay. Yeah, well, I know for certain we have a couple more talks up. Either Brian or Rob. Are you ready?
Rob.
There you go. Rob. Right.
Ryan.
Yeah.
Ryan.
I feel like
Yeah,
that's
Brian. Awesome. Good where they're not right now. Brian's going to be talking about.
Yeah, if you came to the Hacker Society talk this week, you already saw a 50-minute version of this, so just go to sleep or something. But so all I want to do is talk. This is more of a public service announcement than really any sort of tech talk in any way. So HTTP, right? If you work on the web or near the web, this is a big part of your life. It really runs everything that we do. But HTTP 1.1, that spec was defined more than a decade ago now, and we're kind of hurting for a new one. And the most likely candidate for us to we're currently looking for proposals for the next HTTP, it'll be 2.0, is Google's Speedy protocol. And so what this means is that HTTP is going to be actually semantically, it's going to drastically impact you if you work anywhere around the web. And this is evident in such ways as Speedy will multiplex connections between, and it's all over SSL. So this means that you need a common IP and a common SSL certificate in order for you to multiplex. So a common technique that we use nowadays in order to, Fred will know about this at Yelp, in order to increase how many assets you can download at a time is by sharding all of your assets, right? So you have media 1, media 2, media 3. And this is beneficial because browsers can only open, say, I think, what's the number nowadays, 6 connections to?
Between 2 and 8, depending on what browser you use.
Yeah, so you can only open so many connections at a time. With Speedy, the goal, because we can multiplex now, will be to have a single asset server, and we'll just multiplex it all over that one connection. So, Speedy is kind of cool. HTTP 2.0, it'll be years before it comes out because the IETF moves at the speed of syrup. But I don't know, just keep watching it because it's going to be really cool to watch, and maybe even get involved and try to make it, make it more beneficial for all of us instead of just beneficial for Google, who is basically driving the spectrum. That's all I did.
Doesn't Chrome and Firefox want that already?
Yeah, Speedy's out there. You're using Speedy. If you go to Google right now using Chrome or Firefox, you're using Speedy. Speedy 3. Speedy 4 is in the works right now.
So can we set up Speedy ourselves?
Set up. Yeah, there are modules for Speedy for Nginx, Apache. There's a, yeah. If it's a web server, it probably has something with Speedy nowadays. For Nginx, you actually get to apply a patch and then recompile it. But you can do it.
But only Chrome as a browser supports it?
And Firefox.
Okay, so if you visit Google with IE,
You're not going to be using Speedy.
so, okay.
And my website. If you go to Speedy. Yeah.
So you've told us in theory why Speedy is advantageous. Can you give me anything concrete, or what should I expect? What kind of performance improvement would I expect to see by implementing Speedy?
So the idea here is that, so HTTP is kind of what I consider personally, and this is a very kind of squishy topic, but I consider it one of the most elegant kind of software engineering protocols we've ever devised. No, it really is, because combined with REST and those sorts of things, you have a request and a response. What Speedy has said is that if you're Google or you're Facebook or you're any of these big websites, we can't afford to have this kind of nice, elegant solution anymore. This is very much an engineering solution. So what Speedy does, it's an application layer protocol still, but it's actually if you have the 7-layer OSI model, it's actually in layer 5, so it's in the session layer. And so we have actually a bit level protocol defined for opening frames between, so it's running on top of TCP still, but you have frames and streams that are open, you have streams between server and client, and you actually have server push as a part of the Speedy spec, and all sorts of stuff like that. So yeah, there will be.
Does it require applications to be rewritten?
No, well, it requires like the server. You need a module for Apache. You need the patch for Nginx, but you're actually like logic. You don't have to rewrite. You have to
applications that
re-architect.
will write like HTTP headers out there.
So Speedy maintains the HTTP semantics so far as headers are concerned, which is the reason why it can be HTTP 2.0. So that will be fine. It does compress the headers, which we currently don't do, and it also uses a dictionary for the compression. So you see a lot of savings. If you have a lot of little packets, or a lot of little assets that go back and forth, you'll see drastic speedups. For instance, this rings true to me. I was an intern at Yelp this summer, and you go to a business page, and there are 40 reviews, and there are 40 tiny little user images on the page, right? And that's a bunch of requests. With HTTP, the headers are a large portion of the bandwidth that you're using. But with Speedy, that'll be drastically reduced. Oh, yeah.
Do you see it as having any kind of relationship to the WebSocket standard?
It's kind of weird, right? So I didn't make it very obvious in what I'm saying right now, but I'm not a big fan of how Speedy works. solely because it breaks a lot of the kind of HTTP warm fuzzy that I get. And WebSockets actually performs a similar function of push back and forth. But what WebSockets doesn't provide is the pathing. So you have your HTTP paths, right? You don't get that with WebSockets. You have to implement all of your routing to logic functions yourself. However, another proposal for HTTP 2.0 is from Microsoft, called Microsoft S&M. And it's basically Speedy, except they use WebSockets instead of defining their own binary protocol.
It's not that painful to use.
Yeah. I don't know why they named it that. I really don't. Yeah. So cool. Is Rob ready? Where's Rob? Oh, Ish. Okay, cool. Thank you.
If somebody else could go first, I could transfer what I have to somebody else's laptop and show it.
So, I'm gonna take a lead from Brian and also call my public service announcement. I'm gonna call my public service announcement the richness of text-based application layer protocols. So, unlike Speedy, which is not text-based, there are quite a few protocols, including most of the protocol that powers our email, the protocol that some people still use for email, and then of course HTTP, which are all text-based, all application layer, all can be done by a person typing the command line. So, So, starting out, I've set up an email account for myself, and I'd like to send myself an email. So I'm going to hook up to Case's SOTP server. Figure out my IP address so I can give her an actual IP address. I'm going to tell the server hi. This is a sort of a Android use my correct email address. That's optional, by the way. Then send it to the email address I want to send it to, which is. I don't know what my password is. It doesn't like me. Please guess. So it doesn't like me today. Switch to a different protocol. In the meantime, there's a wonderful protocol called HTTP, which we can also use. So yeah, it'd be great if I had. So I'm going to connect to Google. As Brian said, the current version of HTTP is 1.1. You can see that right in my request. Spell it correctly. Okay, Google. Now, this is literally what your web browser does. It does it a lot faster and better. And then it just renders all this output, and you get Google. It's fun. There are other fun examples. You'd be surprised how much of what you type in just gets redirected. So if I go to 4chan, and actually, sorry, I'm going to go to P8. post 4chan.org. And it goes, oh, I'm sorry, I moved it permanently. You'll see that it returned a status code right here, 301. And it says, you should look at this location instead. So, why don't we do that? It's also all safe for work as long as you just stick to the terminal. So, by the way, this tool, NC Netcat, it's really valuable for any sort of debugging. You can connect directly to a TCP socket. The one thing I really dislike about it is it doesn't tell you the state of the TCP connection. So I don't know if it's established successfully. I don't know if it's failed to establish a connection. So if I just try to connect to this port, it won't tell me it failed. I screwed that up. Yeah.
Nginx.
Yeah, it uses Nginx and Cloudflare. It also, you get nice little information like what server everyone uses, which is accessible through other means, but this is nice too. And there are all these nice links, and like I could click on one of these thumbnails, but I'm not going to. All right, back to email. Now, you'll notice that Case's mail server was not happy with me because I was on an open network and they didn't want it to be used by my computer to send spam. Now that I'm on their authenticated network, the other nice thing is that they actually tell you you've got the syntax error. Like usually when you're in a protocol, it's saying, oh, you've deviated from the protocol. No, you get a syntax error. And nice messages. Like theoretically, the computer doesn't need sender OK. It can just do it the 250 status code. I'm sorry. Is that better? I can do fun things here, like my name. You can put anything here. That's how BCC works. If you don't put anything, they don't see who else was sent. But I can make it look like someone else got the email, like, I don't know. And subject. And then just a dot finishes the message. So it should be delivered soon, and then Biden, or in this case the email account I set up, goes to check their messages. So their account is with Gmail. So they do. POP is a protocol that no one uses too much anymore. It's still available. The port for it is 110, but Gmail started using a different port because they wanted it to be all over SSL. So there's another tool called STunnel. And it will connect me to Gmail. It says hi. So I go user. I mean, the account can exist after this. So I have one message, and then retro retrieve. Thanks, Firefox. And you can see, oh, I even got a junk mail status. Apparently my message is not all that handy. Even though I forged the header. And you can see all the nice stuff that we built. I never showed you. Sorry. And that is all. I don't think I speak any other protocols globally. So.
FTP.
Yeah, I was gonna
I
say.
don't speak FTP. FTP is really
The
annoying.
control channel.
Yeah. All right, thank you.
All right, I think there was a Thomas Murphy signed up to do a live chat. Oh, that's Tom. Excellent. What are you going to be talking about?
I'm talking about the GNU Privacy Guard, which is also another public service announcement, basically. Okay, so the GNU Privacy Guard. So what it is, it's called GNU PG. It's a set of tools that offers symmetric and asymmetric encryption, a key pair management system with key server access built in, and digital identity signing, which is a consequence of asymmetric encryption. GPG is also it's completely GPL and is completely free open source. And for those of you who may have heard of the earlier systems, PGP and PGP2, pretty good privacy, is a complete replacement for each of those systems and is completely interoperable with previous messages, providing how to encrypt keys. So installing GPG on GNU Linux, you're likely to already have it. Package managers use this to verify your binaries, and you can download the source of either the 1.4 version or the 2.0 version directly at this site here. I'll have links again at the end. And all the functionality of GPG is offered directly through the command line tool, but there are many front-end interfaces available listed on their website. And those range from ones for specific file management to actual email integration, which is what I'm talking about specifically in a moment. And it's compatible with just about any system that you can find. For macOS, there's a single installer. You just get one disk image with all of the precompiled files on it, including the native GUIs and extensions for operating with other applications. It currently supports 10.6 and 10.7, actually on 10.8, they're currently developing that right now. And below, we have a whole bunch of little icons that they decide to use. On Windows, there is a program sponsored by the German government that's GPG for Win. And this is very similar to the macOS project. It's also free and open source, and it's a set of tools and the actual program precompiled and ready to install. So after you get that, key generation is really easy. Each of these has a good interface that clearly explains what it needs and what it plans to do, either graphically or in text in the command line. For purposes I'm promoting, we want a key that is a RSA key pair that's 1024 bits or greater. You have your name and your email, which you can add further identities later through the interface. And then you're going to want a memorable and unique passphrase to protect your private key. So this whole public-private key thing uses a trust model. And you use this by identifying someone and their key. This key, the key that you see is their public key that can be distributed anywhere. Then you confirm association between them and their key, and then use your private key to sign their public key, saying that this person and this key are associated. Then you can share that signature with the world by uploading to a key server, which then shares among all other key servers. And then anyone who's tracking that person's public key can check their key server to see what the latest updated signatures are. So using the system alone, your key only really works for signing, because that's what you do with your private key, is you can take information, be it a block of text in an email, or even a whole set of files, and say, yes, this is from me, this is my file, and it will be able to tell someone on the other end to use your public key to verify that, yes, this is the file that this person signed. With another person's public key, you can do the interesting thing, is encrypt data to them. When you get some encrypted data from someone, you decrypt that data using your private key, and then you can verify any signatures on that data using the sender's public key. And then the applications of this are secure messaging and then signing code in binaries most frequently. For further information and to download this, there's a set of links and my information including my key identifier if you want to contact me. Any other questions? Yes?
I think I wonder, why don't people, why isn't this more popular? Why don't more people use it?
It just never really became popular, I guess. It's something that requires critical mass to make it actually popular. Personally, I've only encountered one other individual who actively signs their emails, who I didn't personally set up their GPG account for them, or help them get it installed. So it's not something that's widely used, and it's something much more used in the enterprise region, and isn't so commonly used now. Anything else? Yes.
What would you say to someone who would say that signing, in the era of Gmail, which you have to log into with two-factor authentication, that signing emails is no longer necessary?
It may well be.
Okay.
Yes.
Well, as we got a demonstration earlier, you can send email from anyone you want. So, I mean, yeah, Google has GKI now that over checks it, so.
That is a good point. Is that this would be associated directly with identities on public key. And so even if it says from Thomas Murphy, and it has some signature associated with it, if it's not the signature associated with that key right there, that would not be sent from my particular public, signed by my private key that I use for sending emails from this address. Anything else?
You know, when upgrading stuff on Linux, I'll admit sometimes I don't bother to check the code is properly signed or not. Do you think that's a mistake?
With security, something like this, technically, yes, that would be a mistake, because if someone was attacking you and felt so inclined to replace your incoming source or binary with a malicious source or binary, as soon as you install that, if their source or binary already has a built-in feature that detects that it's verifying source code for itself, it would be able to intercept that and return a valid signature found when indeed he was actually receiving either additional bad code or even the correct, or apply no signature found or improper signature found for the correct code, because it can verify based on its own internal signatures what you're receiving. So if you're planning for this to work properly, you really should actually check, but you may not. Thanks. Anything else? Yes.
So maybe I'm not understanding the protocol 100%. Like, let's say I'm a bad person, I want to send this group email from you. So can I go onto the key servers and change the record of your public key to a new public key that I'm saying is yours, but it's actually mine, and then sign the message I'm spoofing it?
And that's where the public trust model comes in.
Okay.
Because your new key, even though it has my email address on it, won't have signatures. And if my key, public key, has signatures from all of you, and one of you gets an email allegedly from me, and you see that key doesn't have signature from one of your friends in the room, you go, wait a second, is this actually from this person? And so what happens is, that's what the establishing identity between key and person is before you sign. It's critical, because if you sign a key, you're saying, yes, this key is this person. And so you can sign on 4 different levels of trust, from minor to ultimate, which ultimate is technically only supposed to be used for your own key. But 1 through 3 is saying, probably know this person, pretty sure this person, absolute confirmation. And that's what's supposed to prevent someone from just adding additional keys and impersonating someone else, because they would have trouble establishing their identity to other signers of the public key. Anyone else? All right, thank you.
Thanks, Thomas.
You're welcome.
Rob, is your talk reading?
Sort of, sure.
Okay. Well, I don't think we have anyone else in their turn, right, Josh?
No.
Okay. So, whenever you're ready. Whether that's now or later.
That actually happened.
No, just do a live food, yeah. Watch Rob typing.
Well, it's gonna be long watching you type anyway.
How many typos does Rob make when lots of people are watching?
All of them.
Yes. Oh, very good, Tom. Typo. Wait, text space. I'm not sure it
Well, Dr. Marlon, hey, Fred.
Drag it over.
Open up system preferences.
It should be configured. Oh, yeah, just, here.
So my laptop fell off the shelf a couple months ago, and I got something that doesn't work with VGA. It makes me sad. So how many of you guys have used text editor like Vim or eMaster now? By the way, old guys, this talk basically isn't going to apply to you. We should already know half of this. No, actually not Ed. So you know how you get the characters on the screen that do some stuff? Like you can see everything, and you can go up and down and move this cursor around. And it's kind of magical, actually, if you think about it, because when you've written code in the past and you print out text, like you don't get this. If you're trying to get this effect, you have to print out an entire screen of text, you know, with all the stuff where it should be, and the user would see that scrolling by and be all sorts of terrible. Fortunately, that was never really a thing. So back in the old days when we had terminals and so on, and bandwidth wasn't so cheap, it made a lot of sense to have a windowed GUI made out of text. And to make sure you didn't have to refresh the whole screen and send all those bits across, you just set up this agreement between your programs and your terminal, so they could send out an escape sequence and move the cursor somewhere else and start updating a different part of the screen, or clear it, or in fact get the number of, or to get the current location if the user's done something. Combining that with the ability to change your standard in from a line buffer to a character buffer input, so I can get individual keystrokes like hitting J a bunch. I don't have to hit J, enter, J, enter, J, enter to get that J in there. You can make a pretty good GUI out of text in your terminal. And so that's what Vim does, and that's what Emacs does, and that's what Nano does, except for the good part. And that's what Ed doesn't do. So let me show you. This is going to be terrible. So this is just a list. You can find VT100 escape sequences everywhere on the internet. Some of them are going to be wrong, or some of them aren't going to be valid anymore. But you can take some of these sequences and make your terminal do cool things. So for instance, this one's pretty great. This lets you move your cursor to a particular location. So you print out escape ASCII character, which is octal 33, and then a bracket, a row, a column, and your cursor, your terminal will move that cursor where it needs to be. But you shouldn't have to remember any of that, because I'm talking about modern text mode graphics and not old stuff. So instead, we can I mean, people have already done this. So there's this thing called curses. This is up here. Curses is a library for cursor optimization. So when you're moving stuff around the screen and putting things in different locations and scrolling up and down and you don't know what's going on, Curses knows what's going on because you've been telling Curses to do that instead of telling the terminal directly. And Curses can actually make the process of typing out lots of things in different locations pretty fast, which is important if you want to update the screen a lot of times in a short amount of time. So the terminals have slow. So this is basically what you can do to get that effect. Include curses linked against it. Linking against it with so you can initialize a screen so curses knows how to do things. Disable character echoing. So when you type things in your terminal, the terminal also types those characters right back at you. It displays them on your screen. So if I want to press J a bunch, you get to the bottom of this page, then I'm going to be pressing J and J is going to pop up every time, unless I turn off character echoing, which is what Vim does and what I'm doing. You can turn off this line buffering by either using this half delay thing, which is kind of special, or you can use CBreak, which turns into a kind of raw mode. That's kind of you can get the current size of your screen, and there are lots of interesting ways that your terminal can report that, and you shouldn't know any of them because people like Eric S. Raymond and so on wrote term cap, term info, and end curses, and all these things work together, and you don't have to touch anything. And so on. Clear clears the screen, so you don't have to worry about the crap that's on the screen from the previous person. Here I have something to move over to a certain location and type in a character. You can get characters within the half delay mode that I had up there instead of CBreak. This turns something called error if the user hasn't typed something in. So you can get real-time text entry without having to mess around with IOCTLs or FCTLs or whatever. I don't remember what going on break is. Unlock this. So you just call refresh and you're done. And when, yeah, so let's see what it looks like. I basically created the world's worst Tron program here in the last few minutes.
Boom.
Boom, I died. I'm terrible at Tron. It doesn't help that there's only one of me playing right now. So that's basically something you can do. This took me last 2 hours of sort of doing this and actually listening to talks and eating lunch. And And so curses is actually a pretty good way to get a GUI quickly, if not necessarily a good one. So let's actually talk about things that aren't quite so immediately obvious right now. This is your cursor, right? It's in a place. That's because this text exists and it was moved here. Bash is actually something like a cursor's application, because it prints stuff out and takes stuff in and knows when to stop echoing and so on. But the real fun part is readline, actually. So readline knows where your cursor is because it can ask. And when you hit the up arrow, it figures out what the last command you typed was and prints it out. And then if you hit up again, it backspaces a bunch. It kills the current line, finds the next thing, and prints it out again. So, like you guys have been using terminal curses forever. You have noticed. So all this text mode stuff really actually kind of applicable stuff, because you can make a nice user interface, a nice simple one that's more complicated than what's on. That's more flexible than you might hope from a text-based interface. And then you can do cool things. So I was typing this out a couple minutes ago. This used to be a popular pastime, right? No. This used to be a popular pastime, actually, among people maybe even 10 years ago, 20 years ago. Is you have what's called a .plan file, or you have a Usenet post or something, and you put maybe an animation into this. I'm not so sure about Usenet. I mean, I don't think I would let anybody type raw escape sequences into my mail. But you can like this you can't see this right now because there's an invisible escape sequence in there. This is what it kind of looks like. So I have this thing, it's an Andalusian video snail, and I'm patting the back of them, and every 10th of a second, I'm printing this guy out, and then moving him back, not quite all the way to the end. So let's see what it looks like. It's an animation. People made some pretty crazy ones. And that's just from doing certain things like for instance, I can what? Let's do this one. I like this one. I can change the color of my text. That's how this happens. I can I can fail at typing that in.
Wow.
I can move my text over to the middle of the screen. Actually, it's better if I do this. In fact, that clear command is actually it's one of these. Well, if it's not implemented directly by the terminal, you're using it shell. Then it's actually outputs when it's escapes. See, I showed that at the bottom of the screen. I typed in large row number, row number, and column number, basically in the center of the screen. And if you could see some of the responses, because the cool thing is about the terminal is it can show responses back to you in the same format. It will give you escape sequences, basically. Unfortunately, you can't really see those as a user, which you're not supposed to be. Unfortunately, this terminal kind of sucks at determining what an escape sequence is, and not showing you all of it.
Hey, Rob?
Yeah.
We're going to wrap this up in a couple minutes.
Yeah. I was at the 11th column when I pressed the button. It would show you where your row was, but beneath that up so that you could see it. So yeah, that's basically how text node graphics works. You can ask me about this later if you want.